Hello students, today I will begin with the second module in the microwave and antenna, and I am going to discuss the concepts related to microwave network theory. And in the previous semester we all have studied about the network theory, and I hope you understood what is network, different types of networks, how to simplify the complicated network circuits, right? Where you also come across what is a junction. And here we just have some additional term which is microwave, and we also discussed what is this microwave. They are similar to electromagnetic wave, but they have a very high frequencies in terms of what? A gigahertz, right? So basically network refers to, it is a interconnection of elements or components. If you take a simple electronic circuit or a network circuit, it may be a interconnection of resistors or capacitors, or it may be a resistors or inductors. Basically it is an interconnection of the passive components through some lines, or you can say some media. So therefore, how we can define a microwave network? The microwave network is nothing but, it is an interconnection of the various microwave devices and components. We have many microwave components like resonators, attenuators, phase shifters, right? Waveguides are there, right? So when you connect these kind of microwave components together, we form a microwave network, right? And we also come across a term known as a microwave junction. Basically this junction is a point where multiple microwave components get connected, right? So this is all we are going to discuss in this chapter, right? So microwave network is formed whenever several microwave devices and components like attenuators, resonators, filters we have, amplifiers, when all these components are coupled together through some transmission lines or waveguides for required transmission of microwave signal, and such network is known as a microwave network, right? And how these devices or components are interconnected at some point, and that point is considered as junction, right? And for a very low frequency, a simple port is nothing but a pair of terminals. As you studied in network theory, you have come across a two-port network where you have got the two ports, the input as well as output port, right? So both with respect to current as well as voltage. So for a low frequency network, a port is a simply pair of terminals, whereas for microwave network, a port is a reference plane. This is very important. So for microwave network, we have to consider a reference plane which is always perpendicular to the length of the microwave transmission line or waveguide, right? And for low frequency network, the dimension of the network or the physical size of the network is much smaller than the wavelength of the signal is being transmitted, right? So if you consider the wavelength of the signal, right, which is much larger compared to the physical dimension of the network, right? Therefore, because of the larger wavelength compared to the physical size of the network, the measurable input and output variables. What are these measurable input and output variables? If I say, they are nothing but voltage and current, right? And for any two-port device, as you know, the voltage and current variables are related to the various parameters like the impedance parameters, that is Z parameters, admittance parameter, that is Y parameter, and we have hybrid H parameters, and also we have ABCD parameters. These ABCD parameters are also known as what? The transmission parameters, right? So you can see here we have a two-port device, right? So here we have input current as well as voltage. So here we have output voltage as well as current, right? And with the help of these variables, input current, input voltage and output voltage, we can define all four parameters, right? And here we have another equivalent two-port network with respect to input impedance, that is the impedance we have at the generator side, and here we have output impedance, right? And here this is characteristic impedance Z0 related to the device, and here we have external, the load impedance. This A1, B1, A2, B2, they are nothing but what? The peak amplitudes, of voltage at the input side, and the peak voltage amplitude of the voltage at the output side. So this is incident, so this is reflected at the input port, and here we have A2 is the transmitted, again B2 is the transmitted, and A2 is again the reflected, that is the return signal from port 2 to port 1. And here we have the incident power, that is the input power Pi, right? So here you will get output power P0, and here out of the incident power, the sum of the power is getting reflected, so that is given by PR. So the sum amount of power is reflected, the remaining power which is transmitting to the port 2, that is nothing but what? Pi minus PR. So if you subtract the reflected power from the incident power, so that amount of power is going to deliver to the output of the device. So this is about the simple two-port network, which is characterized by what? The various parameters like Z parameters, Y parameters, H parameters, and ABCD parameters. So here we have how the input voltage, output voltage, currents are defined in terms of what? The Z, right? So here we have impedance Z parameters, right? So here the output voltage, right? The voltage is defined, voltages are defined in terms of what? The impedance parameters as well as current. So P1 and I1 are the voltage and current at the port 1. P2 and I2 are the voltage and current at port 2, and these are the parameters, Z parameters. Then how to define this Z parameters in terms of voltage and current? So this P1 is equal to Z11 I1 plus Z12 I2, right? And P2 is equal to Z21 I1 plus Z22 I2, right? Similarly, if you want to calculate this Z11, this Z11 is given by what? Basically impedance is nothing but, it is a kind of resistance, we can say, right? Resistance is voltage divided by current. So this Z11 is nothing but P1 divided by I1, and this Z12 is defined as P1 divided by I2. Z21 is equal to P2 divided by I1. Z22 is equal to P2 divided by I2. Similarly, for admittance parameters, the current is now going to related with the voltages. So how the input is going to related with these parameters as well as voltages. I1 is equal to Y11 P1 plus Y12 P2. I2 is equal to Y21 P1 plus Y22 P2. So similarly, how we define the Z parameters, you can also define the Y parameters, right? Y11 is equal to, so this impedance is nothing but, it is a reciprocal of the impedance. Admittance is nothing but, it is 1 over impedance, right? If impedance is equal to V by I, then admittance is I divided by V. So Y11 is nothing but I1 divided by V1, Y12 is nothing but I1 divided by V2, Y21 is nothing but I2 divided by V1, and Y22 is nothing but I2 divided by V2, right? So similarly, we have one more parameter, that is hybrid parameter. So here I have taken input voltage as well as output current, and here I have taken input current and output voltage. So V1 is equal to H11 I1 plus H12 V2, I2 is equal to S21 I1 plus S22 V2, right? So again we'll discuss this. Already you have studied, no need to discuss, no need to give more time on this one, right? So here you can see the diagram. Here we have V1, V2, right? I1 is there, I2 is there, right? So this I1 is nothing but I1 plus I1 minus. I1 plus is nothing but the incident wave of I1, and I1 minus is the reflected current of I1 at port 1, right? Similarly, I can define I2 as I2 plus I2 minus. I2 plus is the positive current, that is transmitted current at port 2, and I2 minus is what? The reflected current at the port 2. So here, so in the I2 plus I2 for current at port 2 is outward, you can see this is outward, and minus I2 taken for current at port 2 is inward, means it is getting reflected towards port 1, that is it is inward from the port 2. And Zij, Yij, ABCD are suitable constants that characterize the junction, that is microwave junction. And compared to Z parameters, admittance parameters and hybrid parameters, the ABCD parameters or the transmission parameters are more convenient to represent any junction whenever the number of circuits are connected together in cascade, that is networks are connected one after the another, right? So one 2-port network which is connected to the another, next which is connected to the another, right? Like when you connect more and more number of circuits in cascaded, what I suggest is, so ABCD parameters are more convenient to represent each junction rather than the Z, Y and H parameters, right? And these parameters can be measured under both short as well as open circuit condition for the use of the circuit analysis. And at microwave frequency, this point is already discussed in previous slide, that at microwave frequency the physical length of the component of our line is comparable to much larger than the wavelength. What I pointed out in the previous slide is what? For very low frequency, the physical length or the physical size of the network is very small compared to the wavelength of the signal being transmitted. And for a microwave frequency, it is exactly a reversed manner, that is the physical length of the component is much larger compared to the wavelength of the signal being transmitted. Therefore, the voltage and current cannot be defined at a given point in a single conductor waveguide, right? And the measurement Z, Y, H and ABCD parameter is also difficult at microwave frequency due to following reasons, right? So here what you have to understand is, what I am going to explaining about is, when you use the ABCD parameters as well as ZYH using the 2-port network, it has got some disadvantage, because since we are dealing with a microwave frequency, so when you are using microwave frequency with some waveguide, we cannot use the ZYH and ABCD parameters because for high frequencies the physical length of the component or transmission line is very small compared to the very large compared to the wavelength, and also the voltage and current cannot be defined uniquely for a given point in a single conductor, right? Then, so that is what I explained in the first point. And a short circuit, especially open circuit, are not easily achieved for a wide range of frequency. So this is the second point, the second reason. The first reason is what? The voltage and current cannot be uniquely defined at a given point over single conductor waveguide, right? And the second point is the short circuit, especially open circuit, are not easily achieved for the wide range of frequency, right? You can use, but only over a limited frequencies. If you take a wide range of frequency, no, we cannot use the short circuit and open circuit concept. And the third point is the presence of active devices makes the circuit unstable for short or open circuit. Even if you want to work with the short or open circuit, but with respect to the active devices, the circuit becomes unstable. So we have to go for the stable circuit. For that we need to have what? The wide range of frequency with the help of the new parameters. I will be discussing in the next slide about the new parameters. So they are the parameter solution for all these the drawbacks. Therefore, the microwave circuits can be analyzed using the new kind of parameters known as S parameters. S stands for what? The scattering parameters, which linearly relate the amplitude of the scattered. So scattered means it is reflected come transmitted at the output side, right? So the signal which is going outward is transmitted, and the wave or signal which is reflecting inward from the photo, that is the reflected waves with those of incident waves, right? So in this slide, so what we can conclude is, right, why can't we use, why we cannot use the Z, Y, H and ABCD parameters to analyze the microwave circuits, right? So what are the reason, right? And the reason we discussed, and what are the solution to overcome these problems, right? I said the voltage and current cannot be uniquely defined, right? So short circuit and open circuit cannot be easily achieved for wide range of frequency. The presence of active devices, if you use active devices, ultimately the circuit becomes unstable over short and open circuit, right? And the ultimate solution for this is what? We have to go for new type of parameter known as S parameter, which is widely applicable for all kinds of microwave networks or circuits, right? So before I discuss in detail about S parameters or scattering parameters, so let me discuss the properties of Z and Y matrices for a reciprocal network, right? So you have discussed different types of networks, right? So theorems also, reciprocity, reciprocal networks with the concept of reciprocity, then superposition you have studied, right? Many network theorems you have studied, right? So in reciprocal network, what happens is, if you measure the power from input port to output port, which is exactly symmetrical when you measure the power from output to input, right? So I is ith port, you can say the port 1, and J is what? Output J port. In either case, if you measure the power from port I to port J, or ith port to jth port, or jth port to ith port, the power you get remains same. So that is the beauty of the reciprocal network, right? Where Pij represents the power at the reference plane I due to the input voltage at plane J. Similarly, Pji is nothing but the power at jth port with respect to the voltage at plane I. From the admittance matrix representation, so in just the before two slides in back two slides. From the admittance matrix representation, we defined Y